Good morning. And now in today's session, we will deal with Fourier integral. Fourier series we have completed. Now we are going to learn about Fourier integral. Now here first of all we will derive an expression for Fourier integral. That is how that Fourier integral will look like, the equation. But you need not bother about the derivation. I am just presenting it just to make you understand the concepts. Okay, no need of learning all this steps and all, because for exams most probably you will be asked problems to solve based on Fourier integral. That is, you will be given a question and you will be asked to find the cosine Fourier integral or sine Fourier integral, like that. So no need to worry about the derivation of Fourier integral. The derivation of formula for Fourier integral. You only need to learn problems, that is, try to work out as much as problems that you can. Okay, similar to the one that I am presenting here. Okay, so anyway, we will go through this derivation first, then we will do two problems. So here Fourier series of f of x in the interval from minus L to plus L. This I think we have already discussed. It is of the form f of x equal to a0 plus sigma n from 1 to infinity an cos n pi x by L plus sigma n from 1 to infinity bn sin n pi x by L, equation 1. So here the formula to find a0, an and bn is given below. Now you just use these values of a0, an and bn in equation 1. That is, just substitute the values of a0, an and bn in equation 1. So your equation 1 will look like this. Okay, now here what they have done is, this term is kept as such. Then here they have taken the common term, that is 1 by L minus L to plus L f of t. That is, that particular terms are common in this one as well as in this one. So 1 by L integral from minus L to plus L f of t is taken outside, and what is remaining? These two are remaining, the cos terms. Okay, that is cos n pi t by L and cos n pi x by L. So combining this, you can write it as cos n pi x minus t by L. See, this is how this is written. Now again the next step, this is kept as such. This term is taken as common. So within bracket there is a 1, this because this is taken as the common term. Then after that this term is written as such, but a 2 is written. Why? Because when this 2 and 2 get cancelled, what is it? The term that is left is same as this one, right? So you are writing it in an alternate way. You are just putting a 2 inside. Then 1 by 2L minus L to plus L f of t. Then what they are doing is, inside this bracket they are multiplying with a term, that is pi by L. Okay, here also 2 is here, already here, pi by L. So this term and this term is multiplied with the pi by L. Then this one they are rewriting, this term is kept as such. Now pi by L, in place of pi by L, that is written as such, they are introducing a term like this, cos of 0 pi x minus t by L, because that is same as 1. So it will be pi by L itself. Now the remaining term they have written in this way, that is, they have written this term as this. This is nothing but cos 2 cos theta is cos theta plus cos minus theta. In that form they have written. Here your theta is this. So cos theta plus cos of minus theta. Just put a minus. So they are splitting this term in the form of 2 cos theta as cos theta plus cos of minus theta. Then they are just rearranging the terms. There is nothing more, nothing is added. They are just rearranging the terms. Now here Next step is that they are removing that summation. Instead of that, they are applying a limit. This one is kept as such. Limit n tending to infinity pi by l. Pi by l is written in this way, 1 by l by pi, which is same as pi by l. Then they are introducing a term like this. A summation from r from minus n to plus n cos of r by l by pi x minus t dt. They are just introducing a term like that. Now when in that term, when l tends to infinity, 1 by pi also tends to infinity. So this is again written in a particular form. They are introducing another integer, say u, delta u tending to 0. Here delta is nothing but 1 by l by pi. This one they are replacing it with a letter u. So limit delta tending to 0 sigma from r from minus infinity to plus infinity cos of r of delta u x minus t del u, where del u is 1 by l by pi. Now finally the expression reduces to equation 3, which is minus infinity plus infinity cos of u x minus t du. Now just use equation 3 in equation 2. That is, what was the equation to this one? In that you are using this equation 3, 2 will become f of x is equal to 1 by 2 pi minus infinity to plus infinity f of t of minus infinity to plus infinity cos u x minus t du dt. That is, that here you can see double integral, that is called Fourier integral, and it will hold good if x is a point of continuity of f of x. So as I already said, no need of by hearting, because all these terms and all will be confusing. No need of learning all that, because they won't ask you to derive the expression for Fourier integral. They will ask you only to solve problems based on Fourier integral. So if you can, you just by heart this integral. Okay, what is Fourier integral? Then so we have seen equation 4, this one. Now the second integral in equation 4, that is this one, the one that is given in bracket, is rewritten as minus infinity to plus infinity. We have already studied it is split into two, that is from first one minus infinity to 0, and then from 0 to infinity. The rest is kept as such. Now just reverse the limit of integration. Minus infinity to 0 becomes 0 to minus infinity. So for that you have to put a negative sign. Everything is kept like that. Now here just replace u by minus u in the first term. In this term replace u with the minus u. Then you will get an expression like this. That is 2 is 0 to infinity cos u x minus t du. So in the Fourier integral that is given by equation 4, we have seen a term like this, right? In equation 4, see this term. So instead of this term is equivalent to this one, right? 2 integral 0 to infinity cos u x minus t du. So in place of this term in equation 4, just use this term. So you will get equation 4 as this one. Okay, this is another form of Fourier integral, this one. So this is one another form. The first one is that given by equation 4. The second form is that given by equation this one, and there is one more form, that is this one. Okay, that is also, so we have come across 3 different forms of Fourier integral. Okay, so just try to learn those 3 forms of Fourier integral, that is enough. No need of going through the derivation of Fourier integral, because questions are not asked till now. If you are interested, you can refer some books for that derivation. Otherwise you just concentrate mainly on the problems only. Okay, so if you can, you just learn those 3 forms of Fourier integral. First one as that given by equation 4, then the one given by this one, and finally that given by equation 7. So study those 3 forms of Fourier integral, that is enough. Now, so just now we have found the three different forms of Fourier integral. Now we are going to find the Fourier integral for odd function, and then we will find Fourier integral for even function. For exams, you will be asked problems regarding this odd function and even function. I mean only problems, not derivation. Okay. Now let us see the Fourier integral for odd function. If f of x is an odd function of x, we have already seen f of minus x will be minus f of x. Then our this term minus infinity plus infinity f of t cos u x minus t dt can be splitted as minus infinity to 0. Then from 0 to infinity, everything else is kept as such. Equation 8. Now just replace t by minus t in the above expression and we will get it as equation 9. Now use equation 9 in equation 8. Then equation 8 will be of this form. Okay. This is simple. I am not explaining. There is only some substitutions. That is, first replace t with minus t. You will get equation 9 and then use equation 9. Then using equation 9, equation 8 will reduce to this one. Then 0 to infinity f of t is kept as such. Then see this one, 0 to infinity f of t is common, and after that these two terms are written inside the bracket, cos u x minus t minus cos u x plus t. Okay, again what is cos? This is same as cos a minus b minus cos a plus b. What is it? 2 sin a sin b, right? So this one is actually, this one is 2 sin a sin b. See, 2 sin a sin b. Okay, so you just expand it and find. Then substituting in 7, so we have also just try to work it out by yourself, because I am here, I am giving only the concepts. Based on those concepts you try to work it on yourself. Okay, and if you have any doubt, refer to this steps. Okay, but no need of learning all this for the exam. You will be asked only problems. Okay, now so now substitute this one in equation 7. What will be that? F of x will be 2 by pi 0 to infinity du 0 to infinity f of t sin ux sin ut dt, which is your equation 7, this one. Okay, you are substituting that in equation 7. So now you are changing the order of integration that is given in equation 11. 2 by pi is kept as such. 0 to infinity f of t dt is taken common. Then after that 0 to infinity sin u t sin ux du. That is dt and du. Those integrals are interchanged. So these equations, that is 11 and 12, both represents Fourier sine integral. Okay, that is Fourier integral for sine function or odd function. So learn that equation 11 and 12. Similarly, Fourier integral for even function. For even function, f of minus x will be f of x. The procedure is same as that we have already discussed for odd function, except for a few change. That is, in place of f of x, it will be f of x itself, not minus f of x. Okay. See, the first step as in odd function, minus infinity plus infinity, minus infinity to 0, 0 to infinity. First you are splitting it. Then what you do, just like before, replace t with the minus t. And then after that, taking the common term, here you have cos a plus b plus cos a minus b, which is nothing but 2 cos a cos b, equation 13. Again you substitute this equation 13 in 7, and finally you will get equation 40. Change the order of integration, you will get 15. So this 14 and 15 stands for Fourier integral for cosine function or even function. Okay, so we have learned 3 forms for Fourier integral and 2 forms for Fourier sine integral and Fourier cosine integral. Okay, so here derivation I am presenting just for you to make, just to make you understand the concept, that's all. From the exam point of view, you will be asked only problems based on this. Okay, so this is one such problem. So try to work out similar such problems as much as you can. Okay, Now, here the question is find Fourier cosine integral. See, find Fourier cosine integral of the function. Function is given as e raised to minus x. Okay. So, since it is a Fourier cosine integral, you first write the formula that you have learned for Fourier cosine integral. Okay. Now, 2 by pi kept as such, 0 to infinity kept as such. What is your here cos ux du, that is also kept as such. Now what is your, what remaining is f of t and cos ut dt. Okay, what is your f of t? E raised to minus x, that is written. Then what is remaining? Cos ut dt, that is also written here. Okay, now our aim is to find, or our aim is to evaluate this one first. What? Integral 0 to infinity e raised to minus kt cos ut dt. That you have to integrate first. But please remember, there are some terms remaining. What is it? 2 by pi 0 to infinity cos ux du. So once you get the answer for 0 to infinity e raised to minus kt cos ut dt, remember to put all these things back. Okay, so first let us evaluate integral 0 to infinity e raised to minus kt cos ut dt. It is written here. Okay, 0 to infinity e raised to minus kt. What is cos theta? There is one form for writing cos theta. What is it? E raised to I theta plus e raised to minus I theta by 2. Okay, that is cos theta. Now what is sin theta? E raised to I theta minus e raised to minus I theta by 2i. That you have studied in complex numbers, right? So this cos theta is written in this form. Which form? E raised to I theta plus e raised to minus I theta by 2. Okay, that is written here. 1 by 2 taken outside, 0 to infinity. Now this e raised to minus kt is taken inside, and then you group it. Okay, then what is the next step? You are applying integration first to this one, that is this, and then applying integration to this one, that will be this one. Okay, now 1 by 2, it is common. What is this denominator? It will be k square plus u square with a minus sign outside. Now how you got the numerator? You just expand this one. Okay, and then after that you group the terms accordingly. That is, group the terms that is common for e raised to iut and group the terms which is common for e raised to minus iut. So you will get this term. Then after that, this is kept as such, this is kept as such, this is taken outside. Now this one, what remaining is this and this. So this one they have written in another way. That is, what is actually this? E raised to iutk plus e raised to iut iu minus e raised to minus iutk plus e raised to minus iut iu. So just expand all these things. So I square term will come, so that will get minus, and then group according to this one, that is 2k and 2u. That is, you have to bring it one in terms of cos term and one in terms of sin term. So group accordingly, then only you will get this expression. So finally 2 and 2 will get cancelled. These two will get cancelled. Okay, so what is remaining is this one. It is written here. Then here what is remaining? K. This is actually cos ut, right? Okay, then this is actually u sin ut. Here they have just reversed the order, so a minus is taken outside. That is why here you are having only k square plus u square, not minus of k square plus u square. Okay, now on applying the limit, this will reduce to k by k square plus u square. Okay, so that is the value that you have obtained by evaluating the one that I have shown before, that is this one. Okay, k by k square by k by k square plus u square. But you have something left, which are they? 2 by pi, 0 to infinity. Then substitute here the value that you have got, then write cos ux du as such. That is what which is written here. Okay, now in your LHS, what was it? It was your function in the question, that is e raised to minus kx. So here take all this 2 by pi to this side. So finally your integral, this one will be pi by 2k raised to minus ks is equal to integral 0 to infinity cos ux by k square plus u square du. Okay, so here read carefully the question. Here you are asked to find Fourier cosine integral and the given function is e raised to minus kx. Now here you are asked to find Fourier sine integral and the function is same, e raised to minus kx. Since the function is the same, the process of integration is the same as that you have done above, that is for Fourier cosine integral. So I am not repeating, but here I have applied a simple technique for evaluating. See, everything is the same, right? But the only thing is that in the above function, in the Fourier cosine integral, this was e raised to iut plus e raised to minus iut by 2. Okay, since it is sine here, there is only a change in this. The evaluation of integral and all is the same. So here I have followed a different method for solving that equation, uh, which is different from what I have shown above. So if these steps are easy, then you can follow these steps for the above evaluation of integral also. Okay, whichever one is easy for you, you can follow that. Otherwise you follow your own steps. Okay, first you write your own steps, you try to solve by yourself. Okay, because this is just integration, that is we can reach the answer in any way that you do. So first you try to do the integration by yourself. If you are not getting, then you follow my steps. Okay, so this is I have written in an elaborate way. Okay, and finally everything is the same. Here see, in the above case you got it as k by k square plus u square. Here it is u by k square plus u square. Then you substitute back everything that is integrals that is left, and procedure and all is the same. Okay, so try to work out these two problems first by yourself. If you have any doubt, go back to the steps that I have shown, and then after that you try to work out more such problems from the reference books. Okay, don't get bothered about the derivation of Fourier integral, Fourier cosine integral and Fourier sine integral, because you will be asked only some problems to solve like this, similar problems. So try to work out similar problems that I have shown here as much as you can. Okay, so today itself you try to work out these two problems. Okay, thank you.